Our next objective is to interpret what's called a p-value. So Coach Rady claimed that he's an 80% free throw shooters, but he shot 50 shots in a random sample of 50 free throws, and he only made 32. So he shot 50 and only made 64%. So now we have some evidence about his claim. And we want to know, does that evidence support the null hypothesis, or does it support the alternative hypothesis? And the way that we do this is we say, how likely is that he only makes 32 out of 50? And if we think about what the sampling distribution would look like for him shooting 50 free throws, assuming that he is an 80% free throw shooter, we'd expect it to be centered at 80%. So what we did here is we did a simulation where we simulated an 80% free throw shooter shooting 50 shots, and we did that 400 times. So each of these red dots represents a sample of 50 free throws and the proportion that he made. So you can see in the 400 times, only 3 times did he shoot 64% or less. So we have some pretty good evidence here that it would be unusual for him to only make 32 out of 50 if he was an 80% free throw shooter. And that's exactly what a p-value does. A p-value assumes the null is true and calculates the probability of that sample happening. So it assumes the null is true and it calculates the probability of that sample occurring. So again, essentially what we're asking is, we've got evidence that is evidence against the null that he's not an 80% free throw shooter, but is it convincing? So how likely is it that an 80% free throw shooter will make only 64 or less out of 50 shots, 64% out of 50 shots? And so from this simulation that we did, we figured out our estimated p-value. I'll show you how to calculate a p-value in the future. As of now, you just need to understand what a p-value is. So he only made 3 out of 400, and that is less than 1%. So this is a very small p-value, which is some strong evidence against the null and allows us to believe that we do not think he is an 80% free throw shooter. So the key for a p-value is it's the probability of the sample occurring given that the null is true. So to interpret this p-value, what we would say is, if Coach Reedy was an 80% free throw shooter, there is less than a 1% chance he will only make 32 out of 50 free throws by chance alone. Once we've interpreted our p-value, it helps us to understand our next objective, which is make the appropriate conclusion. So when we're making a conclusion, we are either going to reject the null or we are going to fail to reject the null. So what that means is, in reality, all we can say is, if we reject the null, we say, we do not think he is an 80% free throw shooter. We have evidence for the alternative. Our only other option is that we don't have enough evidence to reject the null. So if let's say he made 75% of his free throws instead of 64. Well, 75 is pretty close to 80. So we don't have enough reasoning to say we think he's less than an 80% free throw shooter, because sampling variability could account for that difference between 80% and 75%. So if the results are extremely unusual, that we wouldn't think they've occurred by chance alone, then we call those statistically significant. So if the observed result is unlikely to occur by chance alone, then we get a small p-value and we reject the null. If the observed result is not unlikely to occur by chance alone, so the p-value is larger, then we fail to reject. So in a nutshell, it's pretty simple. If it's a small p-value, you reject the null. If you have a large p-value, then you fail to reject the null, meaning we don't have enough evidence to say it's incorrect. So how small does it have to be for us to actually reject the null? That's where a significance level comes into play. there are three common significance levels: 1%, 5%, 10%. And we're going to pick a significance level before we start any significance test. And then we will just measure our p-value against the alpha level or the significance level. Again, the three common significance levels, or most common, are a 1% significance level or alpha level, a 5% alpha level, or a 10% alpha level. So for our problem, our p-value was smaller than all three. So we would reject the null at all three alpha levels. Now, if our p-value was larger, say our p-value was 12%, then we would fail to reject at an alpha level of 10%. We'd fail to reject at all of them. Now, the important thing is you pick your alpha level before you start your test. So you're not going to measure them against all three alpha levels whenever you do a test. You're going to have this selected, or you'll be told the alpha level to use at the start. So if the p-value is less than alpha, then we say the results are statistically significant at the whatever alpha level it is, but the results are statistically significant. So in this case, our results are statistically significant at the 1% alpha level. And we reject the null because we think he is less than an 80% free throw shooter. Let's take a look at an example problem for interpreting a p-value and making conclusions from a significance test. Calcium is a vital nutrient for healthy bones and teeth. The National Institute of Health recommends a calcium intake of 1,300 milligrams per day per teenager for teenagers. The NIH is concerned that teenagers aren't getting enough calcium. Is this true? Researchers want to perform a test where our null hypothesis is the mean is equal to 1,300, or the alternative is we think it's less than 1,300. So mu is the true mean daily calcium intake in the population of teenagers. So they ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals a sample mean of 1,198 milligrams and a standard deviation of 411 milligrams. After checking that the conditions were met, researchers performed a significance test and obtained a p-value of 0.0729. Explain what it would mean for the null hypothesis to be true in this setting. So if the null is true, the mean is equal to 1,300, then that means the mean daily calcium intake in the population of teenagers truly is 1,300 milligrams. Which would also mean they're getting enough calcium. But you can see we got a sample mean from their sample that is much smaller than 1,300. So is it small enough or rare enough for us to think that the null is incorrect? The way we answer that is by looking at the p-value. So our p-value is 0.0729. What that means here is that assuming the null is true, it's the probability of this sample occurring. So assuming that the mean daily calcium intake in the teen population is 1,300 milligrams, there is a 0.0729 probability of getting a sample mean of 1,198 milligrams or less by chance alone from the random sampling process. So when you're interpreting a p-value, there are a couple important things. First, you have to assume that the null is true in context. So assuming the mean daily calcium intake is 1,300 milligrams. Then the p-value is actually the probability, so that needs to be said, of that sample occurring in context. That sample or one more extreme occurring. So 1,198 or less. And then you also need to make sure you specify the sample size. You're saying for a sample of 20 teens, because that's what they had in the problem here. So what conclusion would you make at an alpha level of 10% or a 10% significance level? You just measure the p-value against alpha. 0.07 is less than 10%. So that means we reject the null. So we reject the null because our p-value is smaller than the alpha level. And we need to make sure we say, we really need to follow this sentence format. Reject, measure the p-value against alpha. We have convincing evidence that teenagers are not getting 1,300 milligrams of calcium per day on average. So we have evidence that the null is not true, essentially is what we're saying. But what if we measured this, which we wouldn't do this for an actual test, but what if we were to measure this at a 5% significance level instead of the 10% significance level? Because our answer will be different. We'll measure our p-value of 0.072 against alpha. Well, this time it's greater. So if our alpha or if our p-value is greater than alpha, then we fail to reject because we don't have convincing evidence. So again, we fail to reject because our p-value is larger than alpha, and we're following the same sentence format where we reject, measure the p-value. We do not have convincing evidence against the null in context. So here, reject, p-value, we have convincing evidence. So that's the only two possible outcomes. We either have convincing evidence or we don't have convincing evidence. So you need to make sure you're justifying using this sentence format. Another important note about making your conclusions is that we can never accept the null hypothesis. We reject, we fail to reject, but just because we fail to reject, we don't have enough evidence against it, doesn't mean it's actually true. So we can never say we accept and say that the null is true.